This is Algebra 1. This is our spring from test week number 9 study guide. Starting off with two multiple choice problems. One of them says which one's not scientific notation. One of them says which one is written in scientific notation. Remember, for scientific notation, the number has to be between 1 and 10. So we got 3, that's between 1 and 10, 6.7, good, 8.7. That's too much right there. That one's not written in scientific notation. The first one, D. D. 2 says which one is written in scientific notation. Well, this one right here is too small. It's not between 1 and 10, and negative number is not between 1 and 10. It's got to be a positive between 1 and 10. You have two numbers up front. Both of them are between 1 and 10. That's the first criteria, so you met that one. This one says times 10. This one says times 100. Times 100 is not scientific notation. A for that one. We're simplifying these expressions. Anything to the 0 power is 1. Anything raised to a negative value is going to ride the elevator. So that says negative 4 to the negative 1. It's over 1, so when it rides the elevator, the whole thing, when it rides the elevator, it's going to go down 1 over negative 4 to the positive 1, which is simply negative 1 over 4. Negative 3 is being raised to the negative 4th power for number 5. It's going to ride the elevator 1 over negative 3 to the positive 4 this time. A positive, an even exponent means it's going to be positive. Negative 3 to the 4th power, 3 times 3 is 9. And the other 3 times 3 is 9 times 9 is 81. So it's going to be 1 over 81 for number 5. And then number 6 says 3g squared t to the negative 3rd. Which one is being raised to a negative exponent? Only t to the negative 3rd. So when it rides the elevator, 3g squared stays on top, t goes down to the positive 3rd. Number 7 says 4 over c to the negative 3rd over d to the positive 4th. Again, the only thing being raised to a negative value is c to the negative 3rd. It goes up. You always put your coefficients first, so you have 4 first. C becomes to the positive 3rd when it goes up. D doesn't move because it's to a positive value. It stays just like that. 15 times 5 to the negative 4. Again, anything raised to a negative exponent rides the elevator and goes down. 15 times 1 over 5, since it went down, to the positive 4. We can put 15 over 1 where we can simplify the rest of the problem. 5 to the 4th power means 5 times itself 4 times. So 5 times 5 is 25 times 5 is 125 times 1 more 5 is going to be 1 over, or 15, divided by 625. Well, we know that the number 5 goes into both. Let's see if the number 15 goes into 625. So divide 625 by 15, and it does not. So the number 5 goes into both. To simplify it into 15 3 times, and it goes into 625 divided by 5. It goes into, we know because we just did it, 125 times. So there's your simplified version, 3 over 125. 2 is being raised to the negative power, to the negative 4. So it goes down the elevator, and it becomes 2 to the positive 4. Times anything being raised to the 0 power is 1. So we're going to be left with 1 over 2 to the positive 4. 2 times 2, 4 times 2, 8 times 2, 1 over 16 for number 9. All of these bases are the same for number 10, 4, 4, and 4. So add 4 to the 4 plus 9 plus 4. We know 4 and 9 is 13 plus 1 more 9, 4 to the 17th power. We'll leave this one in exponential form. We have 6.98 times 6.98. Notice the bases are the same. When you multiply the same bases, you add the exponents. 6.98 times negative 6, or to the negative 6 power, plus 6. Negative 6 plus 6 is 6.98 to the 0 power. Anything to the 0 power is 1. 3j to the negative 3rd times j to the negative 4th. You're multiplying the same bases, j and j. 3j to the negative 3 plus 4 becomes 3j to the positive 1, which is simply 3j. 7x to the negative 8 times 6x to the 3rd. Multiply 7 and 6, and you get 42. You're multiplying the same base as x and x, so you do x to the negative 8 plus 3. That becomes 42 x to the negative fifth. The thing that's being raised to a negative exponent at this point is x. Only that's being raised to the negative 5. So 42 is going to stay on top. X to the negative fifth is going to go down and become x to the positive fifth. You have 8k to the fifth times 5j to the fifth times 5k to the fourth. You can, at this point, multiply all of your coefficients. 8 times 5 is 40, and 40 times 5 is 200. So you have 200 when you put those three coefficients together. Then you multiply the same bases, k and k. Notice the other one's j. You don't fool with those exponents. You have k to the 5 plus 4. And then you have at the end j to the fifth, because you can't add any of those. So the only thing you have to do to simplify this, 200, k to the ninth, j to the fifth. Number 15, same problem as the last one. You can multiply all of your coefficients. Negative 4 times 2, negative 8. Times 5, negative 40. Times 1, negative 40 for your coefficients. Put your x's together. X to the third times x to the negative 8 becomes x to the 3 plus a negative 8, because you're multiplying. Plus a negative means minus. So instead of writing plus a negative 8, we'll just put minus. And then the same thing with your y's. Y to the negative 2 times y to the fifth means negative 2 plus 5. So negative 40 is what you have. X to the 3 minus 8 is negative 5. Y to the negative 2 plus 5 is positive 3. So the only thing right here being raised to a negative exponent is x, in fact. Negative 40 stays on the top. Y to the third stays on the top. X to the negative fifth goes down and becomes x to the positive fifth. That's for number 16. I'm sorry, that's for number 15. We're going to skip 16. 16 got on there by accident. Number 17 says k to the third to the third. Anytime you raise a power to a power, now you multiply them. K to the 3 times 3, which is k to the ninth. Same thing with number 18. K to the 3 times negative 6 to the 3 times negative 6 becomes k to the negative 18th. You cannot leave it like that. It has to ride the elevator when there's a negative exponent. It goes down, 1 stays on top, k to the positive 18th. If you put 0 on top, anytime you divide anything by 0, it'll give you 0. So 1 has to stay on top. Anything being raised to the 0 exponent, or when you multiply 9 and 0, you get 0, is 1. So that's 1 times x to the 2, x to the 7th to the second power, which means x to the 7 times 2, which is 1 times x to the 14th, which you don't have to write 1 times something, simply x to the 14th. Negative h to the 4th to the 5th. So that looks like negative h to the 4th to the 5th, which is negative h to the 20th power. And that's going to stay just like that. It doesn't have to ride the elevator because it is a positive exponent. 3k to the 8th to the 5th. Both of them get the 5th power. So 3 gets the 5th power. And k to the 8th gets the 5th power, which means 8 times 5. So 3 to the 5th power, we know 3 times 3 is 9, times 3 is 27, times 3 is 81. When you multiply that times 3 again, you get 243. And then k to the 8th times 5 is k to the 40th power. Everything's getting the square here. 3 squared, x squared, y to the third squared means y to the 3 times 2, which is y to the 6th. Everything's getting the 6 here. X to the 6th, y to the 6th. Now you have the same, everything's next to each other, which means they're multiplying. You multiply the same bases, x and x, which means you add x to the 2 plus 6. And you do the same thing with your y's. Y to the 6 times y to the 6 means y to the 6 plus 6. Bring your 3 squared down, which means 3 times 3. So when we simplify this, you have 9x to the 2 plus 6 is 8. Y to the 6 plus 6 is 12. 9x to the 8th, y to the 12th. Number 23 says negative 2 g to the 5th, h to the 6th squared, g to the 7th, h to the 9th cubed. 2 is, or squared, is being given to everything. So negative 2 squared acts like it's in parentheses. G to the 5th squared is G to the 5 times 2, which is G to the 10th. And H to the 6th squared is H to the 6 times 2, which is H to the 12th. Everything in the second one is being cubed. G to the 7 times 3 is G to the 21, or the 21st power. And H to the 9 times 3 is H to the 27th power. So negative 2 squared is negative 2 times negative 2, which is positive 4. You can put your like ones together, G and G. 10 plus 21 is G to the 31st power. H to the 12th and H to the 27th power is H to the 39th power. Adding those up because they're like bases. Then you do division. 7 to the 4th divided by 7 squared. So you have 7 as both of the bases. When you divide, you subtract. When you multiply, you add. When you divide, you subtract. So that becomes 7 to the 4 minus 2, which is 7 squared, which we know is 7 times 7, which is 49. M to the 15th divided by M to the 10th means M to the 15 minus 10, which is M to the 5th. M to the 7th divided by M to the 8th. That looks like an 8. Okay, so that means M to the 7 minus 8, which gives you M to the negative 1. We can't leave it like that. You can't have a negative exponent. It has to ride the elevator. It's over 1, so it rides the elevator and goes down. 1 stays on top. M to the first power goes down 1 over M. 27, 3 squared divided by 3 over 7. 3 to the 2 minus 7, 3 to the negative 5. Same thing, 1 over 3 to the positive 5. We did 3 to the 5th a minute ago. 3 times 3, 9, 27, 81. 1 over 243. Do the same thing with your variable exponents here. G to the negative 8th divided by G to the negative 20th. Same basis, so subtract the exponents. G to the negative 8 minus negative 20. We know that that means to add 20. H to the negative 3 minus 4. So that gives you G to the negative 8 plus 20. So 20 minus 8 is G to the positive 12. And H to the negative 3 minus 4 is negative 7. The only thing being raised to a negative exponent here is H. So G to the 12th is going to remain on top. H is going to ride the elevator down and become H to the positive 7th. That's number 28. Everything is being squared here, 3 and T and 5. So you have 3 squared, T squared, and 5 squared. Simplify that out. 3 squared means 3 times itself, 9. T squared, 5 times itself is 25. No numbers go into both 9 and 25. Simplified. Everything is squared here as well. 9 squared is going to be 81. We'll simplify it fast. 4 squared is 16. No numbers go into both of those. 31, M to the negative 1, M to the 5th, divided by M to the negative 2, negative 2, everything being raised to the negative 3rd power. Well, they're all M. So you can simplify what's inside first. You have M to the negative 1 times M to the 5th, which means M to the negative 1 plus 5 over M to the negative 2. All of that's being raised to the negative 3rd power. Well, if you simplify negative 1 plus 5, you get M to the positive 4 over M to the negative 2. Again, still all of that being raised to the negative 3rd still. Remember, when you divide, you subtract. So it becomes M to the 4 minus negative 2. All of that being raised to the negative 3rd power again. 4 minus the negative 2 means 4 plus 2. M to the positive 6 being raised to the negative 3rd power. If it's being raised to a negative exponent, it has to ride the elevator going down. So it becomes M, it's a power to a power. It becomes M to the negative 18 because you multiply them, which is 1 over M, since it rides the elevator down, to the positive 18. For this one, we have negative 1 to the 5th power. That is an odd exponent, so it's going to be a negative 1. Negative is odd. Over negative 3 to the negative 3rd power. Again, it is an odd exponent, but it has to ride the elevator down. Or it's already down. It has to ride the elevator going up. So it becomes negative 3, and it's going to be next to it now, to the positive 3. and all of that is over 1. All of that is being squared still. So you have negative 3 to the positive 3. Again, a negative exponent or an odd exponent is going to be negative at the end. So we have negative 1 times negative 3 times negative 3 is positive 9 times negative 3 is negative 27. And all of that is being squared. A negative times a negative is a positive 27. And 27 squared, we know that 27 times itself, 27 is 729 for that one. 33 says to evaluate this expression with these values. So in place of x, we're going to plug in negative 3. So 2 times negative 3, it's raised to the negative third power. And in place of y, we're going to plug in 4. So times 4 to the negative 2. Anytime they have negative exponents, they ride the elevator. 2 stays where it is. So 2, negative 3 gets raised to the third power. 4 gets raised to the second power. Notice both of those become positive. Negative 3 to the third power, again, negative 3 times negative 3 is positive 9 times negative 3 is going to be negative 27. So you have 2 over negative 27, which is right next to 4 squared, which is 16. So you have to multiply what's on the bottom. 27 times 16, or negative 27, we should say, times 16, and we get 432. So 2 over a negative 432. The number 2 is going to go to into both of them, since they're both even numbers. And it's going to become, we'll put the negative on top, negative 1 over 216 is your simplified version for number 33. We could do the same thing with the next one. You have values for x and y. In place of x, we'll plug in 2. So we have 1 over 2 to the negative 2. X's value is 2 to the negative 3. And in place of y, we'll plug in negative 4. So times negative 4 to the 5th. So we'll simplify this. Anything being raised to a negative exponent rides the elevator. So this goes up, and it becomes 2 squared. This goes up, it becomes times 2 to the third. Negative 4 to the 5th power is going to stay right where it is. Negative 4 to the 5th, because it's raised to a positive exponent. 2 squared is going to be 4. It's right next to times 2 to the third. 2 times 2 times 2, which is 8. Over negative 4 to the 5th power, when you evaluate that exponent, it's an odd exponent, so it's going to be negative. You get 4 times 4, which is 16. The other 4 times 4 is 16. And then when you multiply that times 1 more 4, 16. When you multiply it by 1 more 4, you get 1,024. And it's going to be negative again because it's an odd exponent here, 5. So 4 times 8 is 32 over negative 1024. See if the number 32 goes into both. It probably does. It's also, it goes into it 34, 2 times in fact. So negative 1 over 32 is your simplified version for 34. 35 starts scientific notation. Remember, in order for something to be in scientific notation, it's got to be between 1 and 10. So the only spot you can put it to make it between 1 and 10 is right there. 3.91 times 10. It's a great big number, so it's going to be a positive exponent. Just count how many times you got to move it. 3 times, 6 times, 7, 8 times 10 to the positive 8th. This is a very small number, but again, it still has to be between 1 and 10. Only that spot right there, 3.32, is going to get it. Find out how many, it's times 10, how many times you have to move it. You have to move the decimal once, twice, 3 times. It's a very small number, so it's negative, and you moved it 3 times. Going from, that was from standard to scientific. This is from scientific to standard. This is a positive, so it's going to be a big number. This says 8. The decimal's not shown, so it's right there. In order to make a big number, you move to the right that many times that it says, 4 times. So 8 with 3 zeros filled in, or 4 zeros filled in, is going to be 80,000 for 37. 3.67 times 10 to the negative third. It is a negative exponent. It moves the other direction. It makes a very small number. So you have 3.67. You want to move it over 3 times, once, twice, 3 times, that way. So 0.00367 for number 38. 39, you're doing 3 times 9, which is 27, and the same base is 10 and 10. Times 10, you add the exponent, 6 plus 3. So 27 times 10 to the ninth. What's wrong with 27? So what's wrong with the number 27? It's not between 1 and 10 because to write in scientific notation. The decimals here, it has to move 1 time to the left to become 2.7 times 10. If you move it left, it increases from 9 to 10. So 2.7 times 10 to the 10th. Do the same thing with 0.04 and 0.07. You can multiply those. You know 4 and 7 gives you 28. And when you move that decimal twice, you get 2.8. And do the same thing with the same basis, 10 and 10. You can add the exponents. So times 10 to the negative 6 plus a negative means minus 2. So we have 2.8 times 10 to the negative 8. This is, again, why scientific notation is special. The whole thing rides the elevator. This is a whole number. It's not separated. So this becomes 1 over 2.8 times 10 to the positive 8th power. Oh, I'm sorry, for scientific notation, you actually don't need to ride the elevator. You can leave it just like the way I got it circled originally. That makes it a very small number. You move it to the left 8 times if you're making standard notation. But we want scientific notation, we'll leave it just like that. The number 2.8 is satisfactory because it's between 1 and 10. This is an example where both things get the negative 2 exponent. So 2 is being raised to the negative 2 times 10 to the 15 times negative 2. Remember, power to a power means to multiply. So this is a case where the whole thing needs to ride the elevator and go down. 1 over 2 squared is going to be 2 to the positive 2 times 10 to the negative 30, which is going to give you 1 over 2 times 2, since you do it times itself twice, it's 4 times 10 to the negative 30. And again, that's scientific notation. Negative exponents work in scientific notation.